Throughout history, humans have demonstrated an incredible ability to adapt to and thrive in all different kinds of environments, whether it be a desert or rainforest, snowy mountains or muddy bogs, vast savanna or tiny islands. You could almost guarantee some member of the human race calls it home. There are, however, a few sections of the globe that still, for the most part, elude us. Many of these far-flung, inhospitable corners of the world will soon be home to new research stations and experimental structures testing the very limits of humanity's ability to tame, or at least coexist, with the wild Earth around us. Take Antarctica. Arguably the least inhabitable place in the world, it is the only continent that has remained largely free of human inhabitants for the vast majority of history. It's easy to see why this is, with temperatures reaching a bone-chilling minus 70 degrees Fahrenheit in the winter, climbing to a, by comparison, balmy 14 degrees in the warmer bits near the coast. Now, thanks to research stations studying the climate and the history of the least welcoming landmass in the world, the continent is home to a small population of year-round inhabitants clinging to the coastal warm pockets through the winter months, though that year-round population has never maintained more than about 1,100 people. The ice-covered continent, specifically Antarctica's South Shetland archipelago, is about to get a few new inhabitants thanks to the new Henry Arctowski Antarctic Station, a Polish research station set to complete construction by the year 2023. The Arctowski Center is a new housing and research unit, adding to the existing research center established on the archipelago's St. George Island in 1977. Developed by the firm Kurlowitz and Associates, the research station features many adaptations to help the structure and its inhabitants cope with the hostile terrain. The lab is built in a triangular shape with 3 separate wings coming off the 3 triangle points. This is to shelter the entrance to the building, built into the inner angle from the worst of the wind and drifting snow coming off of the adjoining Admiralty Bay, the majority of which will be deflected into opposite directions off the outstretched wings of the building. The building is raised off the ground to allow some snow and potential floodwater to pass underneath, thereby avoiding entrances and windows being covered by drifts or creating drainage issues. The exterior is plated in gold-colored paneling, meant to soak up heat from sun rays. The building is built on a double slant, the walls of the upper floor slanting down, and the walls of the lower floor slanting up. This will make it very hard for snow to cling to the outside of the building, relieving scientists of the common northern chore, clearing snow off the roof. What snow does manage to stick to the guiding will quickly melt and drip off due to the gold plating's heat sink functionality. The lab will support 29 scientists and plans to feature an internal greenhouse and a multi-level social area in the center of the triangular building. The interior of the building is very Scandinavian. Bleached wood offers a textured, minimalistic backdrop for scientists with plenty of storage and comfortable living spaces. The light-colored wood is an age-old building material for those who live in areas near the poles of our planet, as in the winter these places can sometimes go a month without sunlight. Light-colored wood is scientifically proven to have positive psychological effects on those who must live through such periods of darkness and has been central to Scandinavian architecture for hundreds of years. Thus, the building is designed not only to take care of its inhabitants physically, but also to provide emotional and psychological support to ease the pressures that come with living at the very edge of the world. One mock-up of the common social space even shows a ping pong table. This is clearly meant to be a safe space for these people of academia choosing to live at the edges of our planet, but the question remains, why go to all this trouble in the first place? The short answer? For science. The Arctowski Antarctic Research Station is a prolific center of scientific observation and study. Beginning in 1977, the Polish Academy of Sciences has steered researchers living on St. George Island into some of the most important work being done on the continent. Discoveries and advancements in marine biology, oceanography, geology, geomorphology, glaciology, meteorology, climatology, seismology, magnetism, and ecology have all come from Arctowski over the decades, and more breakthroughs are on the horizon. One of the more promising things coming from this research station is advancements in studying psychrophilic strains of microorganisms, which has huge implications in the field of biotechnology. Another such research station, named Proteus, is also pushing human limitations in order to discover and study potentially revolutionary scientific data. As you may have gleaned from the name, shared by a future-telling sea god of Greek mythology, Proteus is a futuristic research lab project designed for the ocean floor. Heralded as an international space station underwater and the future of our oceans, Proteus will be constructed 60 feet below the Caribbean Sea, designed specifically for 24/7 deep-sea study. Once completed, Proteus will be the largest ever underwater human habitat. The group behind the lab's construction cites a threefold purpose behind their mission, all of which ultimately tie back to climate change. The first reason these scientists want to get so up close and personal with the deep oceans is so they can have an early warning if something is about to happen. The Proteus team cites the rising temperatures of the ocean as a cause behind rapidly growing microbial bacteria and viruses, which researchers may have time to prepare for if they are alerted to them early on in the process. Scientists also explain that since so much about the ocean is unknown solutions to human problems may lie just out of reach below the waves. Their final reason for this extreme research center is fairly obvious. More time underwater will give scientists greater flexibility and variety in the way they study the ocean. The next research station in this video stands out as it's not so much home for scientific endeavors as it is a home designed to be a scientific endeavor. Experimental bioregenerative stations, or eBios, are functional blueprints for closed-loop, semi-permanently self-sustaining villages. The company spearheading the project, Interstellar Labs, initiated the project as an experiment to find a functional model for permanent Martian habitations, which are all the rage now that Earth's most eccentric billionaires are locked in a new space race. And be sure to check out our other videos about SpaceX, Blue Origin, and others. Interstellar Labs began construction on their future space village about 2 years ago, and during the design and testing processes, executives realized that the same principles of self-sustainability, waste reduction, and extreme recycling could be useful for humans a little closer to home in the Earth's battle with climate change. According to the CEO, Barbara Belvisi, to fully design a functional Mars colony, designers need to be cognizant of the human condition. This naturally opens the door to wondering where this technology would help the most people, which in turn steers engineers and scientists towards using this tech for what it does best, gracefully sidestepping the limitations of a harsh environment. Belvisi says that Interstellar Labs tech can help people sidestep the coming limitations of climate change as well as the intended function on the Martian surface. The village is reportedly close to full functionality and plans to open to the public this year. From what we know now, it sounds like the village will offer tours and educational experiences for 6 months out of the year, then function as a research lab, technology testing zone, and astronaut training site for the remaining 6 months. The village, which is in the final stages of its construction, is located in the Mojave Desert in California, keeping with the long tradition of governments and companies using the western United States to simulate the Martian surface. The environment around the village allows realistic testing of water collection technologies and food preservation techniques. As climate change warms some areas of the world, it's hypothesized that more and more land could start to resemble the Mojave. The process is called desertification, and the Intergovernmental Panel on Climate Change calls it the biggest threat of the modern era. Technologies like this food preservation and water collection machines designed for Mars could play a huge part in preventing entire communities from suffering severe consequences in the coming decades. Humans have always been explorers. Now, thanks to emerging technologies, we're reaching and inhabiting the furthest, wildest corners of our Earth and possibly beyond.